Today, we're going to be building an autonomous robotic rover to help with weed control. So in my last video, we built a computer vision sprayer, which used a camera to only spray when the sprayer was actually over weeds. And what this would allow for is reduced pesticide usage, and more importantly, the ability to use organic pesticides, which are much more expensive and therefore need to be applied in a really targeted way, compared to glyphosate and some of the other cheaper but pretty nasty chemicals. So that version worked pretty well to allow me to go through the field and collect some data, but it wasn't super useful because you still had to have a human pushing this thing along to go through the field and spray the weeds. And so this next version is actually going to be closer to a potential real product here. It's still an early prototype, but the idea is to use this autonomous tracked rover that we're going to build to go through fields. It'll actually have a robotic arm on it so it can articulate in the plant beds and then detect weeds and only spray over those weeds. So most of the components I got are going to be in this box, but just to go over some of the stuff we had from the last build, and please check out that video if you're curious, but we've got our solenoid valve that we can hook up to a USB relay, and then our webcam over here. I powered that just with a laptop to start, and that's still what I'm going to be doing with this version before I invest in getting some custom electronics, specifically an NVIDIA Jetson computer to run the computer vision models directly on an embedded device. So some of the other stuff we've got here that's new though is we've got this remote control. The first version of the rover is not going to be fully autonomous yet because first I just want to make sure that the physical vehicle itself is going to work well before we actually start adding a whole bunch of complicated computer navigation stuff. So let's go ahead and get this thing opened up. I got all these parts from GoBuilda, and they are great because they have these modular components. It's almost like an erector set for robotic vehicles. So a lot of these components are things that you can just buy and assemble. I did get a kit for this initial rover, which I'll probably modify significantly, but just to make sure I got everything that I needed, it did come with the motors, the motor controllers, all of the actual metal body parts itself. So I'm gonna just unpack everything, open it all up, and see what we got here. All said and done, I think I spent about $1,300 on these additional components, so I should be able to do this entire build for certainly less than $2,000, but there are components I'm reusing as well. Oh man, you can see the treads here. These things are pretty beefy, which I'm really glad about because I wasn't quite sure how well a rover would work in those muddy farm fields, but I think with these things, they're gonna work out just fine. So we got two of them there, almost 4 inches wide. I've got all the pieces unpackaged here, so let's get started with the build. I'm making sure to use medium strength thread locker here because the rover's gonna be in a rough field, there'll be a lot of vibrations, and I wanna make sure that nothing shakes loose. This is the track tensioner assembly, which ensures that there's enough pressure on the tracks so that they stay on the sprocket. Now that they're both assembled, I'm going to go ahead and assemble the axle and attach the sprockets to the tensioner. Now we're going to mount this tensioner assembly to this U-channel, which is actually going to hold the track. Next, we're going to go ahead and attach the mounting brackets and the motors. So this is a 4-motor setup because it's lower voltage. However, I'm planning to modify the rover later to only use 2 motors, but I'll actually get much more power because I'm going to overvolt the system. But for this initial build, I'm just going to go ahead and follow the kit. Now I'm attaching the pinion gears to the motor shafts, and this is actually going to attach to another axle, which connects the drive pulley with the gear. From there, a belt connects that drive pulley to the actual sprockets so that we can drive the track. Here's the finished assembly, which will hold the track, and basically you just duplicate that for the other side. Now that the chassis body is complete, I'm going to route these wires, but it's important to use a grommet. That protects the wire insulation from rubbing against that sharp metal and causing a short. Now I'm moving on to assembling the tracks. So these tracks are pretty flexible, but it's really important they stay that way and you do not overtension the bolts because that can lead to the track not running properly across the sprockets. So what I'm going to be doing while assembling these is paying attention to how tight I actually tighten it and making sure that it's just as loose as all the other track pieces so that it flows smoothly. Not gonna lie, finishing this track was probably one of the most satisfying parts of the entire build. Also, if you've made it this far, please give me a thumbs up. Subscribe to the channel to support the project or to see future build videos. Before putting the tracks on the actual body now, I need to attach these idlers. So this is gonna hold up the track and prevent it from rubbing on that U-channel. One tip I learned when installing these tracks is that when you're putting the tracks on the sprockets and wrapping them around, you would have to hold tension in order to be able to insert the bolt. But if you slide it over, you can use the sprocket teeth to hold the track in place, and it makes inserting that bolt way easier. Now that we've got both tracks installed, it's time to give her a good roll test. Overall, the wire assemblies for this were super easy because I just used a kit. There is honestly way too much wire here, and so I had to bundle it all up and kind of stuff it into the chassis. So I'll probably go back through later, use a soldering iron, clip this excess wire, and only use as much as I actually need. That should keep everything a lot cleaner, but in order to move fast right now, since I've only got 5 days until the YC deadline, I pretty much just have to do what I can to make this thing work without having to add a whole bunch of extra soldering. Here's the moment of truth. Does it turn on? Yes, it does. Thank God for ChatGPT because these instructions were incomprehensible, but eventually I got it figured out and was able to drive the motors. This is the first test drive. It's working super well. I was honestly surprised by just how well it turned. No matter what I threw at it, it pretty much conquered everything. It didn't matter if it was tall grass, loose rocks, or curbs, it just won over it all. Now I'm attaching my SO101 robot arm directly to the rover. Some of you may remember this robot arm if you've been watching my YouTube shorts. I previously used it in a live stream project where I had a 24/7 live stream and people could send a tweet to the robot and command it to pick up colored rubber ducks. So for this teleoperation test, I had to go back to this robot's roots and have it pick up a rubber duck. I wanted to test how rugged the rover was with the arm mounted, and so I took it on a bit of a test drive, and this thing absolutely cooks. Now it's time to hook up the plumbing, so I'm using the same plumbing setup as I did last time for the computer vision sprayer, but I really need to make sure that it does not leak near all those expensive electronics. So right here, I'm just doing a pressure test. You can see that spray nozzle working. Now I'm gonna go ahead and mount this to the robot grippers. I'm just using a hose clamp, and that actually has worked super well. You can see here where I'm teleoperating the arm, mimicking that sprayer, and it looks like despite the weight of that nozzle, the robot's doing just fine. These wires are an absolute mess, but I wanted to show them off. So I obviously don't have a power outlet out in the field, and I need to be able to control the arm as well as the leader. So I hooked this up to the 12-volt battery. I've got a voltage regulator there. This is the same battery I used to drive that solenoid valve. So I just used some splitters, got it all hooked up, and teleoperation is working just fine. Here's my first live outdoor test. Got that weed on the first try. Overall, I'm pretty happy with this iteration of the prototype. Obviously, it's pretty rough. There's a lot of limitations, but just as something that I can show people and have them understand what this thing is and what it would be capable of, this should work pretty well. So there's a lot of limitations, like the fact that I've got that backpack sprayer that's way too big to actually mount on the rover itself. The plan for that is actually getting a smaller 1-gallon spray tank. And even though it's a lot less liquid, because this is a precision spraying machine, it really doesn't take a lot of liquid to cover a whole lot of weeds. So that's my plan for that part. The next major limitation though is this thing is just remote controlled. I've got a remote control for the vehicle. I teleoperate the arm. Obviously the next step there is going to be adding real autonomy so that the vehicle can navigate for itself, can actually detect weeds and then move the arm to spray them. That's going to be a big challenge, but I'm a software engineer. So of all the parts of this project that I'm actually more equipped to handle, the software is one of them. The hardware was the thing that I was a little bit more worried about if I'd be able to pull it off. And While I think this is pretty simple and rough, it's good enough to at least get that software started and prove the concept. I'm actually going to be taking this out and doing a live demo at the local college because they have an agriculture program and they have some test fields. And I got in touch with one of the professors there, and he's going to let me come out and try this thing. It's honestly been great and super inspirational just to have all of the support that people have shown for the project. Even though my following's not big and it's really early, people have been coming out because this is a problem that actually resonates with them. So I'm very excited to be doing that on Monday. I'll be recording that, and then that's all gonna be part of my YC demo. So I'm applying to Y Combinator with this. Given it's only been 3 weeks since I started, I'm not expecting too much, but I wanna get that initial application in, get some feedback on this project, and then hey, make more content, talk to more farmers, and hopefully recruit some co-founders. So if this project is interesting to you and you're an engineer, especially mechanical engineer, someone with experience with computer vision, SLAM, autonomy, robotics, and you think you might want to contribute to this project, please reach out to me. You can reach me via email, morgankufal@gmail.com, or on Telegram @koofdev. Also, LinkedIn's another good way to get in touch. So please reach out. And if you've got any questions about this project, I'd love to hear them. Please like, share, comment, all that. And hey, thank you so much for watching this video.